Alright guys, welcome to the second video of the fifth chapter of our Java video tutorial series. And in the previous video we talked about typecasting errors and what could cause errors, for us to have errors when we are trying to typecast, like what we had here in this typecasting example 2. So if you're just watching this video for the first time, you should go back to the previous video where we discussed about this error that we had while typecasting. So in this video I want to demonstrate to you and illustrate to you what's actually happening in the computer when we are declaring variables in our source code, like this, like saying short a is equals to 64 and byte b is equals to a. So I need to explain to you what happens. So I'm gonna bring up a Paint application that I can use for illustration. Actually, this Paint application was written in Java, and it's a cool Paint application. So we can select this pencil tool here and adjust the brush stroke. And now what happens is that when you declare a variable, let's say a short, and we are told that a short is a 16-bit sign to complement integer. What happens is that the computer will have to convert that number that you stored in the variable, let's say 64, into binary form, in form of bits. Okay, so if you've heard of the base 2 number system, which we usually call the binary number system, you understand that the binary number system uses only ones and zeros to store its values. So you can't have any other digits except ones and zeros. So that's the language of the computer. That's what the computer uses in storing their information, because the computer only understands ones and zeros, which is equivalent to on and off signals of electric signals. So in the computer's memory, the computer will use on and off signals to store data. So even if you declare numbers, whole numbers like 64, and store them into variables, the computer will only store them in forms of ones and zeros. That's in the binary form. And that also applies to any kind of data that you are storing in your computer, whether it's an image, a song, an mp3 file, a video file, or whatever you have in your computer, whatever kind of file, they are all stored in binary forms. So this is how this goes. In the computer's memory, there's something that we call registers, and these registers, they are kind of like boxes. Okay, so I'm gonna draw a box like this. They're kind of like boxes that contain several sections in your computer's memory, which your computer will use in storing information. So let's say a register was created for the variable that is holding a short. Okay, and you can see that a short is a 16-bit sign to complement integer. So what will happen in your computer's memory is that your computer will create a register that can take 16 bits of data. So we can declare a register that is going to have 16 boxes for our computer's data. So this is just an illustration, so just pay attention. Alright, so how does the computer convert all this stuff into bytes? So let's say we have 64 as the number that we want to store in these boxes, okay, this register. So we're going to use the binary division, which is essentially dividing all these numbers by 2. So 64 divided by 2 is going to give us 32, and it's going to divide it. Then we have to count the remainders. So it's going to divide 64 and by 2, and it gets 32 remainder 0, and then we'll have to divide 32 by 2, then we'll get 16 remainder 0, and then we'll have to divide 16 by 2, then we will have 8 remainder 0, and then we'll have to divide 8 by 2, and then we'll have 4 remainder 0, and then we'll have to divide 4 by 2, and then we'll have 2 remainder 0, then we'll have to divide 2 by 2, and then we'll have 1, remainder 0, and then we'll have to divide 1 by 2, which we can't divide, so we are going to have 0, a remainder 1, because in that division we are going to have a remainder. So so now, if you can still recall, in your primary school we have to count this other way, and that means that 64 in the decimal number system, 64 in base 10 equals 1 0 0 0 0 0 0 in base 2. So what the computer is going to do is that the computer is going to take these numbers starting from the last digit over here, and then put it in here, prick this one and squeeze it over here, put this one inside this box, put this one inside this box, put this one inside this box, this one goes in here. We have 1 2 3 4 5 6, 1 2 3 4 5 6, then this one goes in here. So what the computer is going to do now is that, since these boxes are empty, just fill them with zeros, as no electrical signals are going to be found. All right. Okay, so what's going to happen now is that when you declare a variable in the form of a byte, which is an 8-bit sign to complement integer, you are like telling the computer to declare a register. Let's use some other color here. Like telling the computer to declare a register, which is a box containing some 8 boxes. Okay. So what will happen is that you're trying to tell the computer to pick, these 16 boxes and squeeze it in here. So it's like telling someone to try to force a bigger box inside a smaller box. So that's not gonna work. However, it's pretty much easier for you to force a smaller box to go in a bigger box. So this is not going to work. So but this can go in well. So assuming this other number here was stored in this box here. Assuming this number was stored in this box, so we have 0 1 0 0 0 0 0 0. So assuming we have this number here, it's pretty much easier for us to kind of like pick these digits and place them here and then fill these other ones with zeros. Alright, but it's difficult to do it the other way around, so that's why we're having this error, this compilation error over here. So so that's if we go back to the source code, you can see that in typecasting example 1, we were able to compile this program because a byte was able to fit into a shot, as 8 bits was able to fit into a shot. Implicit typecasting. So we can call this implicit typecasting because we didn't need to do any special stuff. However, if we wish to make this other program to work, which is throwing this error over here, we need to do some explicit typecasting. Now, explicit typecasting is pretty much simple. All we need to do is to put brackets right in front of this variable and type the keyword byte inside the bracket. So it's like telling the computer, okay, I know that I might lose some precision in my numbers, but go ahead and force this short, okay, a variable to convert to a byte. So it's like saying, go ahead and discard any problems that may occur and store it in the byte. So if we go back to the command prompt and try to recompile that program, you're going to see that it's going to compile. So no news is good news. Then when we run it, I'm gonna have what we expected, which is 64. All right. So that's the difference between implicit and explicit typecasting. Let me write it over here. Explicit typecasting. This was explicit typecasting. We had to really specify that we want this short, which is variable a, to be converted to a byte. And this was implicit typecasting when we were saying we want this variable b to be converted to a short, and we didn't have to explicitly state what it needs to be converted to. Okay, so that's it between implicit and explicit typecasting, and I hope you found this informative, and thanks for viewing. Please don't forget to subscribe to our YouTube channel, and don't forget to check out our website, and I'll see you on the next video tutorial.